Chapter number 9, Sequences and Series. First of all, we learn what is a sequence. So here we are having a succession of numbers arranged in a definite order according to a given certain rule is known as sequence. For example, let us take example, say in the set of natural numbers, let us take all uh, even natural numbers. So 2, 4, 6, 8, 10, 12, so on. So this is a sequence. Then another, let us take the set of all the numbers all in the set of natural numbers which are odd. So that will get 1, 3, 5, 7, 9, 11, 13 and so on. Then let us take one more uh, pattern of numbers which have a rule. So let us take uh, from the set of natural numbers those numbers which are prime numbers. So what they are: 2, 3, then we have 5, 7, 11, 13 and so on. Now what is the rule here? You can see very clearly in this before we described about the rule, we can see that the number which is coming first in the sequence is known as first term. So this is first term, this is second term, this is the third term, 4, 5, 6, this is the sixth term. Similarly here, this is the first term, second term, third term. Suppose we are dealing here, so we write the first term as A1, so A1 equal to 2. That means that is the first term. Then 3 will be our A2, that is second term. Similarly, suppose I want to write this one, then counting from here 1, 2, 3, 4, 5, 6. So A6 will be, that is the sixth term. So that is equal to sixth term, and that is equal to 1, 2, 3, 4, 5, 6. So that is 13. Now here again let us go back to the definition of sequence. A succession of numbers arranged in a definite order according to a given certain rule is known as sequence. So what is the rule here? Here we can clearly suppose we want to find the fourth term. Fourth term is nothing but 4 times the first term, because 2 into 4 is 8. You can see the fifth term. What is fifth term? 10. That is 5 times the first number. Similarly, what is the third term? That is 3 times the first number. So here what is the rule? Here we can say in general, an stands for the general term, that is equal to 2n. So in this one, if suppose we need to find the 100 term, then we can easily find 100 term will be 2 into 100, that is 200. Now let us go in the second sequence. The numbers are 1, 3, 5, 7, 9, 11, 13. Now from the first sequence, you see that if from each of the elements of the first sequence we subtract 1, 2 minus 1 we get 1, 4 minus 1 we get 3, 6 minus 1 we get 5, 8 minus 1 we get 7, 10 minus 1 we get 9. In the same way, 12 minus 1 we get 11. So that means, and suppose we write here one more element, say 14, because the next even number will be 14. 14 minus 1 we get 13. So in general we can say that the formula or the rule for finding the nth odd number will be an equal to 2n minus 1. So this is the rule. It's very clear from the observation itself. Now let us see the third sequence. The third sequence, we can see that first number is 2, prime number they are, second one is 3, third one is 5, then 7, then we have 11 and 13, and this is 1, 2, 3, 4, 5, 6, this is the sixth prime number. But suppose same way if you want to say write the 100th prime number, is possible? It is not possible for us unless we go on finding the prime numbers. So that means we cannot write every time the formula for the nth term. So sometime only we can write the rule, but the formula is not possible for us to write. So such sequences are known as progression. In class 10th also we have read one of the such a sequence which was a progression, that is arithmetic sequence or arithmetic progression. It was a progression because we were able to write the formula for the nth term. So when we are able to write the formula for the general term of the sequence, it is known as a progression. So now let us go more in this one. Here we are having a sequence containing finite number of terms is called a finite sequence. So what is a finite sequence? Suppose we limit till here only. In this sequence, if you write only the elements 2, 4, 6, 8, 10, 12, 14, then this will be a finite sequence. But suppose if we increase, go on, that is putting dot, dot, dot and so on. That means when the number of terms are infinite, it is an infinite sequence. And when the number of terms are finite, it is a finite sequence. So a sequence is called infinite if it is not a finite sequence. So in infinite sequence there will be infinite elements. In finite sequence there will be finite elements. Now next here we are having whatever we have discussed, that here in this one, in the sequence of primes 2, 3, 5, 7, we find that there is no formula for the nth prime. Such sequences can only be described by verbal description. So every time, as we have discussed, that the rule is not possible, in that case such sequences are known as progression. So that word will be coming here, I think somewhere it should be here. In case it's not there, but you have to learn it, it is known as progression. Progression. So here you can write down progression. Progression. So what is progression? Those sequences in which we can write the formula for the nth term. Such sequences are known as progression. Otherwise they are simply sequences. For example, in this this is the first sequence we have taken, is the second one, and here we have taken was the third sequence. Out of all these three, the first two are progression. This is a progression, this is also progression. And the third one is simply a sequence, because it is not possible for us. We can write down the rule. What is the rule? That is, it is the we have to write only those numbers which have only two factors, that is 1 itself and the number 1. So the rule is there, that is how to write the elements, but there is no formula by which we can write the we can give the rule for writing the nth term of the sequence. So suppose someone says that what will be the 100 term or what will be the 1000 term. So it is not possible for us to state the 100 term or the 1000 term unless we find all the terms before that. So this is the difference between sequence and progression. Now next let us go for series. What is a series? Suppose here let a1, a2, a3 so on to an be a sequence, then the expression a1 plus a2 plus a3 plus so on plus an so on, if it is infinite, then that is known as a series. And in series, it doesn't mean that we have to go on adding them. Suppose we have the suppose we have a sequence of say even numbers, even natural numbers, even natural numbers, even natural numbers. So what they are: 2, 4, 6, 8, then 10, 12 and so on. So the series will be for this. Suppose they say write the series. Series will be equal to 2 plus 4 plus 6 plus 8 plus 10 plus 12 plus so on. We have not to add them. Simply the terms in the sequence, in between them we have to put the plus sign. So that is series. The series is finite or infinite according as the given sequence is finite or infinite. Series are often represented in compact form called sigma notation using the Greek letter, the sigma Greek letter, as means of indicating the summation involved. Thus, the series a1 plus a2 plus a3 plus so on till an is abbreviated as summation k equal to 1 to n ak. For example, let us take one example. Suppose we have a series and this is 2 plus 4 plus 6 plus 8 plus 10 plus 12 plus 14. So how many numbers are there? 1, 2, 3, 4, 5, 6, 7. So we can write this in compact form as summation k equal to 1 to n ak equal to. So this in short will be this sort, that is 2 plus 4 plus 6 plus 8 plus 10 plus 12 plus 14. So in short we can write this as summation k equal to 1 to n ak, where ak is equal to, where ak equal to, what is ak here, that is 2k, because when k equal to 1 we'll get 2, when k equal to 2 we'll get 4, when k equal to 3 we'll get the third term as 6. So this is the compact form of writing this series. Now next we'll learn what is the meaning of sum of series. Here sum of series, very simple. Suppose we have a series, is there. Let's take the same series. Suppose we have the series 2 plus 4 plus 6 plus 8 plus 10 plus 12 plus say 14, and it says that find the sum of the series. Find the sum of the series. So in series we are not adding the terms, simply we are writing as they are with the plus sign in between the terms. Find the sum of series. In sum of series we will have to add, we have to find the sum total. So here we can write this as find the sum of the series. So summation k equal to 1, then count how many terms are there, 1 2 3 4 5 6 7. So this 7 in, then suppose this ak, and its total will be 2 plus 4 is 6, 6 plus 6 is 12, 12 plus 8 is 20, 20 plus 10 is 30, 30 plus 12 that is 42, and plus 14 that is 56. So sum of this series will be 56. Now let us go in the exercise. So we will be going in exercise 9.1. Exercise 9.1. Write the first 5 terms of each of the sequences in exercise 1 to 6 whose nth terms are. So we have to find first 5 terms, means we have to find A1, A2, A3, A4, A5 for all these sequences. So exercise 9.1, question number 1. Here an is equal to n into n plus 2. So A1 means simply wherever n is there put 1. So we'll get 1 into 1 plus 2 equal to 1 plus 2 is 3. So 1 into 3. So that is 3. So A1 is 3. A2 equal to, when n is there put 2. So 2 plus 2 here we'll write, and 2 into 4. This will give us 8. Similarly A3, wherever n is there we substitute there 3. So in an, wherever n is there we have to put n as 3. So 3 into 3 plus 2. So this will give us 3 into 3 plus 2 is 5, that is 15. A4, what is A4? Wherever n is there put 4, n as 4. So 4 into 4 plus 2 equal to 4 into 4 plus 2 is 6, that is 24. Similarly we get A5. What is A5? Wherever n is there put 5. So 5 into 5 plus 2 equal to 5 into 7, that is 35. So this is how we have obtained the first 5 terms of the sequence. Similarly, let us take question number say 2. In that also the method of solving will be the same. Question number 2 now. An is given as n over n plus 1. An equal to n by n plus 1. So taking n equal to 1, we will get A1 equal to 1 over 1 plus 1, that is 1 by 2. What is A2? Substitute in place of n2. So we will get 2 over 2 plus 1, that is 2 by 3. A3 equal to, wherever n is there we will put 3. 3 over 3 plus 1 equal to 3 by 4. N equal to 4. We will get A4, that is 4 over 4 plus 1 equal to 4 by 5. Similarly, we will get A5. A5 means 5 over 5 plus 1, that is 5 by 6. So this is how we have done question number 1 and 2. And the same way you all will be doing question number 3, then this 4, 5, 6, 7, 8, 9, 10 all. So yes, till 10 you will be doing all the questions. It all will be for self trial. They are very simple questions. Simply you have to substitute the value of n. Here I think till this is question 1 to 6 we have to find a1, a2, a3, a4 and a5, and this question number 7 onwards is very simple. You have to in question number 7 you have to simply find a17 and a24, and in question number 8 only a7, in question number 9 only a9 you have to find, and question number 10 a20. The a20 means wherever n is there put 20, so you will be getting the answer of that one. Then next question number 11. In 11, a1 equal to 3, an equal to 3, an minus 1 plus 2 for all n greater than 1. What we have to do, write the first 5 terms of each of the sequences in exercise 11 to 13 and obtain the corresponding series. So let us do question number 11th one. Question number now 11. So write the first 5 terms. a1 equal to 3, already one term is there. You have to find the remaining 4 terms now. a2 will be, and this formula is to be applied only when n is greater than 1. So here an, if we compare with an, here n is 2 and that is greater than 1. So we can use this formula. So a2 equal to 3 into a, in place of n will put 2 here, 2 minus 1 plus 2. So this will give us a2 equal to 3 into a2 minus 1 is a1 plus 2. So this will give us a2 equal to 3 into, what is our a1? 3. So 3 into 3 plus 2, that is a2 equal to 9 plus 2, that is 11. So a2 will be 11. Then next we will find a3. How to find a3? By applying the same formula. a3 will be here. This is our a3 equal to 3 into a 3 minus 1 plus 2. So this will give us, therefore a3 equal to 3 into a2 plus 2. So a3 equal to 3 into, what is a2? a2 is 11 plus 2. So this will give us a3 equal to 33 plus 2, and that is 35. Therefore a3 equal to 35. Next we will find a4. a4, that is equal to 3 into a 4 minus 1 plus 2. So equal to 3 into a3 plus 2 equal to 3 into, value of a3 is from here 35 plus 2. So this will get, if we multiply this 5 into 3, 15, 1 carried over, 3 into 3, 9, 9 plus 1, 10, 105 plus 2, and that is 107. Therefore we can say that a4 is equal to 107. Now next we will find a5. So what is a5? a5 is equal to, from here again we will apply the formula, 3 into a5 minus 1 plus 2. a5 equal to 3 into a4 plus 2. a5 equal to 3 into, what is a4? 107 plus 2. Therefore a5 equal to 7 into 3, 21, 2 carried over, so this is 0 is there, 3 to 0, 0 plus 2, that becomes 2, 3 into 1, 3. So 321 plus 2, that is 323. Therefore we can say that a5 is 323. And what we have to do is write the first 5 terms of each of the sequences in exercise 11 to 13 and obtain the corresponding series, and also we have to obtain the corresponding series. So therefore series equal to a1 plus a2 plus a3 plus a4 plus a5. Now we will just put the values. a1, from here our a1 is 3 and a2 is 11. So we will write 3 plus 11 plus, now what is a3? Here a3 is 35 and a4 is 107. So 35 plus 107. 35 plus 107. This is a1, a2, a3, a4. And what is a5? That is 3, 2, 3. So this is our series. And we have not to add them, because they are not asking about the sum of the series. What is the question here? Write the first 5 terms of each of the sequences in exercise 11 to 13 and obtain the corresponding series. So this is the corresponding series. So this is how you will be doing question number 12 and 13 also. Now we will go in question number 14th one. Question number 14. The Fibonacci sequence is defined by a1 equal to 1, a2 equal to 1 and an equal to an minus 1 plus an minus 2, where n is greater than 2. Find an plus 1 over an for n equal to 1, 2, 3, 4, 5. So question number 14th one. Here a1 equal to 1, a2 equal to 1. So here, because we have to find this an plus 1 over an for n equal to 1, 2, 3, 4, 5. If we put here 5, we will get 5 plus 1, 6. That means till 6th term we will find first. So here already we are having a1 and this a2. So next we will find a3. What is a3? Because here what it says that when the this subscript is greater than 2, you have to use this formula. Here we can see that if you compare with an, here n is 3 and that is greater than 2, so we will apply this formula. This formula we have to apply, that is a3 is equal to a, put here 3 minus 1, that is a2 plus 2 minus 2, 3 minus 2. So this is here putting n as 3, will get a3 minus 1, that is a2 plus a, putting n as 3 minus 2 is 1, so plus a1. So what is a3? a3 is a2 plus a1, so that will give us therefore a3 equal to, we are having the value of a2 and a1 both, so that is 1 plus 1, so that is 2. a3 is 2. Next is a4. How to obtain a4? Is very simple. a4 will be equal to a3 plus a2, and how we obtain this one? Just put here n equal to 4. 4 minus 1 is 3 and 4 minus 2 is 2, so a4 equal to a3 plus a2, very simple. And we are having the value of a3 is 2 and a2 is, from here a2 is 1, so that is 2 plus 1 equal to 3, so a4 is equal to 3. Next is we'll find the value of a5. So how to find a5? a5 is nothing but the sum of the earlier two terms, that is a4 plus a3. So what is a4? a4 will be equal to, here from here 3 plus, and what is a3? 2. 3 plus 2 equal to 5. And those who have not got this one, is very simple, just put n equal to 5 here. So 5 minus 1 is 4, we will get a4 plus, and 5 minus 2 is 3, so we will get a5 equal to a4 plus a3. So when n is greater than 2, what we have to write? Suppose third term, fourth term, fifth terms, they all will be sum of the earlier two terms. So here, that is why we have got a3 as a2 plus a1. a4 we have got as a3 plus a2. Similarly, a5 is a4 plus a3. So what is a6? a6 is nothing but the sum of the earlier two terms, that is a5 plus a4. What is a5? 5. What is a4? 3. So that is equal to 8. So now we can find the value of this, that is the ratio of an plus 1 over an for n equal to 1, 2, 3, 4, 5. Obviously, when we put here 5, we will get a6 over a5. So that means till a6 over a5 we have to get. So first we will put n equal to 1. So a2 over a1. a2 over a1, just from here, what is a2? 1. 1 over 1, that is 1. Next, we will find the value of putting taking n equal to 2 now. 2 plus 1, 3. So a3 by a2, and we have to find this ratio till where? Till a6 over a5. So a3 by a2 equal to, from here we can get, just put the values. a3 is 2, and what is a2? a2 is 1. 2 by 1, that is 2. Next is a4 by a3. a4 by a3. So finding a4 by a3 equal to, what is a4? From here it is 3 and a3 is 2. So 3 by 2. Next, let us find the value of a5 by a4 equal to, from here you can get the value of a5, that is 5, and a4 is 3. So 5 by 3. The last one, a6 over A5. Why is the last one? Because the value of n, maximum value of n is 5. So putting here, we'll get 5 plus 1, that is A6 over A5. So that is the last ratio which you have to find. A6 over A5. What is A6? 8. What is A5? 5. So with this, our exercise 9.1 is complete.